All right, this is the Math 137 review final exam for day 2. Going to go through and do a few examples from each of the pieces. This might end up being a 2-part video. It just depends on how much I can record in one session. So let's start with number 1. We're going to look at B because we did A in class. So it says you're given a circle with a diameter of 12 inches with a central angle of 140 degrees. We want to find the exact area of the sector formed. So you have to know a formula here about the area of a sector of a circle. And it's A equals 1/2 r squared theta, where r is the radius of the circle, obviously, and theta has to be in radians. It's the angle in radians. So they gave us wrong information for this, essentially. I mean, it's information, but it's not the format we want. If the diameter is 12, that means the radius is 6, and we have to turn 140 degrees into radians. So multiply it by pi over 180. So that's going to be 14 pi over 18 because the zeros can cancel, and that would be 7 pi over 9. So my area formula would be 1/2 6 squared times 7 pi over 9, and we would square that 6, so that's going to be 1/2 36 times 7 pi over 9. Since 36 is even, you can take half of it, so that would be 18 times 7 pi over 9. And 18 is also divisible by 9, so that's going to be 2 times 7, so that's going to be 14 pi inches squared, since this is area. And that's how we want it. We do not want you to give it to us in decimals because it did not specifically ask for that. Okay, let's look at number 2. I decided to do B part here. It says find the exact values of the 6 trigonometric functions of theta if theta is in standard position and px is on its terminal side. So let's plot that point. That would be in quad 2 because it is a negative x but a positive y. So it's got a -8 and a 4 for the x and the y because there's the point up there. And then we can find our hypotenuse by doing Pythagorean theorem. So 4 squared plus -8 squared equals r squared. So that's going to be 16 plus 64, which is going to add to 80. And we'd want to take the square root of that. So that's going to be 16 times 5 is 80. So that's going to be 4 on the square root of 5. Okay, once you know your 3 sides, you can now reference from your central angle here, this part right here, you're going to reference your sine, cosine, and tangent. So sine of that theta is opposite over hypotenuse, so that's 4 over 4 square root of 5. Which is just 1 over square root of 5, or if we rationalize, that'd be square root of 5 over 5. Cosine of theta is adjacent over that, so hypotenuse, so -8 over 4 square root of 5, which is -2 over square root of 5, which is going to be -2 square root of 5 over 5. The tangent of that theta is opposite over adjacent, so that's going to be -4 over 8, or -1/2. Since we have sine, cosine, and tangent, we should be able to flip those to get the others. So I'm going to write them over here. So cosecant of the theta, flip it before you rationalize, so it's just going to be square root of 5. Secant, if you flip it before you rationalize, it's going to be negative square root of 5 over 2. And then cotangent would be the opposite of tangent, or reciprocal, so that's -2 over 1. So there are my 6 trig ratios. Okay, let's look at number 3. It says approximate this to this theta to the nearest 0.1 degrees, all angles in the interval 0 to 360 that satisfy the equation. So when you're trying to solve for a ratio that you don't know, it's not one of your special ones, you're going to use the inverse button essentially to solve for that. So I'm going to go ahead and get that ready. But this would be theta equals sine inverse of -0.5678. That is a negative ratio. You should already expect that sine is negative in quad 4, but sine is also negative in quad 3. Now, because of the inverse function here, you're only going to get a solution that's either in 1 or 4. So we're going to get the angle degrees in 4. So you should already kind of expect that. So this is 0.5678 and it's negative, and we're going to do the inverse sine of that, and that's negative 34 point, it said 1 decimal place, so 0.6. Now that would be how this angle measures right here from the down part. So negative 34.6, I think was what I got. Let me double check. Yes. Okay, so we want that measurement from 0 to 360. So we would do 360 minus that to figure out its positive angle measurement. So I'm just going to add 360 to it since it's that way. So 325.4. So one of my answers is 325.4 degrees. That's my quad 4 answer. I also know that there should be a reference angle of 34.6 degrees over here in quad 3, because that's another place you can have a sine with a negative ratio. For that one, you would need to add 180 plus that to get the angle. So 34.6. So that's going to be 0.6. Add that would be 411. So I'm getting 214.6 degrees. Let me double check myself. So 180 plus 34.6. Yeah, 214.6 degrees. So those are the two places where sine would have this negative ratio, in quad 3 and in quad 4. All right, so I wanted to do another one. I do a cotangent one here. Now you want to make this the reciprocal because you don't have an inverse cotangent button. So the way we do this is you just flip the fraction upside down. You can either say 1 over tangent or you can say 1 over this. Either way, you've turned it into the reciprocal. So then this will be inverse tan of 1 over 0.1234. Notice this is a positive ratio in here, and the two places where tangent are positive is in quad 1 and in quad 3. So I should already expect angles in both of these, except the inverse of tangent only gives you, again, quad 1 and quad 4. So we're going to get a quad 1 answer on our calculator. So 1 divided by 0.1234, that is that, and then we take the tan inverse of that, 82.96. That actually rounds up to 83.0. So 83 degrees. Now that's actually the correct measurement for that angle in quad 1. The reference angle always works out in quad 1. But over here, we're still going to have to add 180 plus that. So 180 plus 83 is 263. So those are my two thetas. All right, for number 4, we're graphing again, and we did A in class, so I'm going to look at B. This is essentially a transformation of a cosine wave, so kind of remind yourself what the cosine wave naturally looks like. This is kind of the parent function. On the natural cosine wave, remember this is 0. We have pi over 2, pi, 3 pi over 2, and 2 pi. It completes its cycle from 0 to 2 pi naturally, and 1 and negative 1, obviously. So this is 0 right here. So remember, on cosine, typically you start up at 0, 1, and then it's down at pi over 2. You're on your baseline now. At pi, you're down at negative 1. At 3 pi over 2, you're at 0 again, and at 2 pi, you're back at 1. So remember, you get kind of a shift of the sine wave. Okay, so that's what it naturally looks like, just regular old cosine. Because this has got a negative in front of it, we know that we're going to be doing the reflection, which means we're going to be down, coming up, and then go back down. So this is the shape I should expect at the end with all the other parameters because it's got this negative in front of it. So let's talk about what we know. The amplitude is the absolute value of the number in front, so that would just be 3. That means, remember, where our graph normally was stretched up 1 and down 1, we're going to be stretching from our baseline. Here our baseline is the x-axis. We're going to be stretching up 3 and down 3 from our baseline. And then we need to find our period. Our period is found by doing 2 pi, which is the normal period for cosine, divided by the absolute value of b. B is the number in front of x. So this is 2 pi over 1/2. So that's actually 2 pi times 2 over 1. So that's 4 pi. So this is actually going to be stretched out further. This wave is going to be stretched horizontally. Our phase shift, now a lot of people do the negative c over b formula. I like to find my start and my end, so I actually use the way of placing it between 0 and 2 pi, since that is our standard period for cosine. And then you solve this for x, essentially. So we'll subtract pi over 2 from all the sides. So this is negative pi over 2 less than or equal to 1/2 x less than or equal to, this is 4 pi over 2 if we make it a common denominator, so this will be 3 pi over 2. And then we're going to be timesing everything by 2 to get rid of that part in the middle. So if we times everything by 2, this is negative pi, x, and 3 pi. Okay, so when we look at this, and I also need to know my max and my min. So this is based, okay, so your baseline is based off of this vertical shift right here. So that means my whole graph is going to be down at -2 for my baseline. So think about 1, 2. So what I like to do sometimes is I draw like, I don't leave this on my final answer, but I draw like a dashed line to let me know